Hey guys, welcome. This is chapter 8 review video. Let's get started. What kind of triangles are these? So let's take a look. First thing you gotta do is verify that they are a triangle. Once we can verify they're a triangle, then we can figure out what kind of triangle they are. Okay, so let's verify. We're gonna use our highlighter here to do this. Okay, so 9 plus 7, so you gotta add the two smaller and make sure it's bigger. 9 plus 7 is 16. It's bigger than 15, so that is good. 4 plus 3 is 7, which is not bigger than 8. That is not good. Okay, so this one doesn't work out, and the reason why, because 4 plus 3, it needs to be bigger than 8, and that's not true. Okay, so that doesn't work. So this is not a triangle. Okay, moving on over here, 8 plus 8 is bigger than 8, so that does work. So we have at least two triangles. Let's go figure out what kind of triangles they are. When we're figuring out what kind of triangles they are, we go ahead and put in Pythagorean's theorem. So it's going to be 9 squared plus 7 squared. And then we don't actually do equals, we just want to see what's going to happen with 15. Okay, so hopefully you know how to do these. This is 81 plus 7 times 7 is not 63. I was thinking of 9s. Is going to be 49. And then we have 225. Okay. 81 plus 49 is going to be 130? I think 130, yeah. 130 and compared to 225. Okay. So, what are we going to do with that? So if they were equal to each other, then this would be a right triangle. It's not. Before we answer that, let's go ahead and go over here and do this one. We're going to get 8 squared plus 8 squared equals 8 squared. Sorry, not equals, but we're going to see what happens. So this is 64 plus 64 and 64. And then we're going to add these together. We get 128. And this is 64. Okay, so this brings up a good question. What is going to happen here? And so let's go ahead and use a different color. So here we see that the two sides are bigger than the third side, and over here we see the third side's bigger than the two sides. So this accounts for an acute triangle, whereas if the big side is bigger, then it's an obtuse triangle. Okay, meaning it has one angle over 90. So these are three different ones that you might see on the test. So make sure you guys are aware of that, and let's go ahead and get another one. Alright, so we're back. Woo! Woo! And let's get started. Okay, so I forgot to put the number in on this one. My bad. We'll go ahead and do that one last. Alright, so this is a 30, 60, 90. I know it's 30, 60, 90 because I got 30, 90. This has to be 60. It's in, 15's in the x rad 3 position. Okay. This is at the x position, and this is the 2x. So you always want to start out by identifying our parts. And we got to ask ourselves, what times rad 3 would give me 15? And if you know our shortcut, we just go ahead and divide by 3. And multiply by rad 3, and we would get 5 rad 3 as our x value. And then 2x, we just double it, and we get 10 rad 3. That's a 3. Horrible looking 3 though, but it is. And those are our three numbers. This one here, we have no angle measures, so what we're going to do is use Pythagorean's theorem. 5 squared and 2 rad 2 squared equals x squared. And we know this is going to be x over here because it's the hypotenuse. A squared plus b squared equals c squared. C is the hypotenuse, it is the longest side. Hey! Okay. And so we got 25. Now we distribute this guy, so it's going to be 2 times 2, or 2 squared, which is 4. And 2 rad 2 squared is going to be also 4. Sorry, not 4, but 2. Add those together. equals x squared. Okay, that's going to become 8 plus 25, and we end up with 8 plus 25 is 33 equals x squared. When we take the square root of this, we actually end up with our final answer, which is square root 33, because that doesn't reduce. So square root 33 as our final answer. Cool. And let's go ahead and go back to green. This was supposed to be, I don't remember, 18, I think. So let's get back to orange. Okay, so this is in the x rad 2 position, and this is x, and this is x. Okay, so what times rad 2 would give me 18, and that would be rad 2 or 9 rad 2. Okay, and again, how do we get this? Simple rule, divide by 2, multiply by rad 2, or you can kind of figure it out. But again, this just takes practice and practice and practice and practice. Okay, let's look at maybe 1 or 2 more, and we'll call it a day. Okay, we'll leave with this last one. This is one of those, what we call a double header. So we have 2 triangles here. I'm going to use this violet color. So, whoops, that is not what I meant to do. I want to use... No one saw that. Alright, we're going to use this violet color. X rad 2, X, and X. These are the locations. So let's go ahead and just focus on one triangle at a time. And 10 is in the X rad 2 position. So what times rad 2 would give me 10? And for that question, we are going to go ahead and, oh my gosh, use blue. And so we can divide by 2, multiply rad 2, so that's 5 rad 2. And over here, we're going to get the same thing, 5 rad 2. Okay, so I'm just finding all the different sides. So I would actually stop here and I'd redraw this other triangle now. Okay, here's my 30, and here's the 90. And what we have is given to us is 5 rad 2. And now I would go in and re-put all of the right pieces. So this is going to be what x equals, this is going to be 2x, and this is going to be x rad 3. So sometimes breaking it into a separate triangle will make it a little easier. Okay, back over to blue. Boom, 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 boom. Okay, so if 2x, we have 5 rad 2, so 2x is going to be 10 rad 2. Perfect. And then over here, we got 5 rad 2, but it's going to get multiplied by rad 3. So 5 rad 2 times rad 3. The radicals will multiply each other, but not the 5. So this will become 5 rad 6. Okay, so this over here is 10 rad 2, if we're going to put it back in the picture. And this will be 5 rad 6. And that was kind of an ugly 5, so we'll redo him. 5. Alright guys, peace out. Good luck on the quiz. And what helpful advice could I tell you to do? One second.